The price function in Rm of x units of x is Px equals to 262 minus x, whereas the price function in Rm of y units of product y is Py equals to 120 minus 2y. The cost function for product x units of product x and y units of product y is Cxy equals to 214x plus 54y plus xy. The first question, find the total revenue function and total profit function when x units of product x and y units of product y are sold. So to find revenue function, we're going to combine two price function and times with x and y respectively. So revenue function equals to x times px plus y times py. So x will times with 262 minus x plus y times with 120 minus 2y, which is 262x minus x squared plus 120y minus 2y squared. So for the profit function, let's denote with pi xy equals to revenue minus with the cost function. 262x minus x squared plus 120y minus 2y squared minus with the cost function. So our cost function here, we're gonna times with negative 1, negative 214x minus 54y minus xy. We're going to get 48x minus x squared minus xy plus 66y minus 2y squared. Now for the second question. Find the number of units and price of each product to achieve maximum profit. So for the first step, we're going to find pi sub x. So let us differentiate our profit function with respect to x. So if we differentiate 48x with respect to x is 48, minus differentiate x squared with respect to x is negative 2x. Differentiate negative xy with respect to x is negative y. And differentiate 66y minus 2y squared with respect to x is 0. Pi sub y equals to differentiate 48x minus x squared with respect to y is 0. Differentiate negative xy with respect to y is negative x. Differentiate 66y with respect to y is 66. Differentiate negative 2y squared with respect to y is negative 4y. Now, let's equal our pi sub x and pi sub y with 0. 48 minus 2x minus y equals to 0. And y equals to 48 minus 2x. And this is our first equation. So for pi sub y, equal it to 0. Negative x plus 66 minus 4y equals to 0. And we're going to substitute the first equation into the second equation here. And negative x plus 66 minus 4. Substitute 48 minus 2x into the y. 48 minus 2x equals to 0. And let us do some expansion a little bit. Negative x plus 66 minus 192 plus 8x equals to 0. So negative x plus 8x is 7x, and if I bring 66 minus 192 to the right hand side is 126. When x equals to 126 divided with 7 is 18. Substitute x equals to 18 into y, and we're going to get 48 minus 2 times 18 is 36, and y equals to 12. So we have a critical point which is 1812. So the third step, we need to find the second order partial derivative pi sub xx, which is differentiate 48 with respect to x is 0, differentiate negative 2x with respect to x is negative 2, differentiate negative y with respect to x is 0. So this is negative 2 pi sub y is equals to this negative x plus 66. If we differentiate with respect to y is 0, so differentiate negative 4y with respect to y is negative 4. Differentiate, we are looking for pi sub xy. So if we differentiate 48 minus 2x with respect to y is 0, differentiate negative y with respect to y is negative 1. Let us use our second order partial derivative for the d-test, which is pi sub xx times with pi sub yy minus pi sub xy square. So negative 2 times negative 4 minus negative 1 square is equals to 7, and we know that if d is positive, we need to check our pi sub xx, which is negative 2 is less than 0. 18, 12 is a maximum point. So therefore, we can say 18 units of product X and 12 units of product Y maximize profit. Now let's find the price for each of the product. So let's substitute 18 into the price function for X. So 262 minus 18 is RM 244, and the price for Y, the quantity is 12. So 120 minus 2 times 12 is RM 96. Now let's find the third question. Find the maximum profit. So to find maximum profit, we're going to substitute 18 and 12 into the profit function. 48 times 18 minus 18 squared minus 18 times 12 plus 66 times 12 minus 2 times 12 square, which is RM 828. So that's it.